Alrighty, first point to mention, had several texts this week. I guess as the homework assignment due date actually approached, people checked the homework, and there is a printed textbook you need. Or PDF, or Kindle, or whatever. Okay, so I'll expand upon that later. But we have a website that we're using, and then there's a printed textbook that we're also using. And they're not the same thing, even though unfortunately they have similar titles. So all the homework refers to the printed textbook, or the Kindle, or PDF, or whatever you got. So if you don't already have it, order it. And I'll give you a couple days slack on the due dates for those of y'all who don't already have the textbook. When you upload your homework, just put in why it's late. Say I didn't have the textbook. Check the syllabus for ISBN number. So speaking of the online text, we were hitting chapter 4 of it. So the chapter for quiz 2 and 3, the quiz for chapters 2 and 3 of the textbook, the physical textbook, is open. Since we finished chapter 2, supposedly, as of the assignments, go ahead and get the quiz done. There's no due date assigned on it, but why wait? The sooner you get it done, the sooner I can grade it, and the sooner you can retake it to get 100 on it, right? So, because that's the way it works. The quiz you get to retake, get a better grade after I grade it. So get it done as fast as possible, and if you don't do the quiz and you get points taken off at the end of the semester, well, you were warned. You know, the quizzes are mandatory. They're not just free, you know. They're worth points, just like everything else. And when I've taught, I've had people in the past like put off the quizzes for, you know, weeks and weeks and weeks, and that's kind of silly. You may as well just get them done as soon as you get the chapter done. Thank you everybody for showing up despite the rain. Rain seems rare until this week. We've been in a real dry spell. All right, so textbooks, as it mentions here, the website is Python for Everyone, Exploring Data in Python 3. That's its name. And then the physical textbook is Python for Everyone. Sorry, second edition by K.S. Horseman. It looks like the same, but they're not. Sorry about that. You got to get that one. Your homework assignments are from there. If you look for section 2.1.5 in the website, you're not going to find it. Okay, so we were talking about functions. There are all these built-in functions. The way you invoke a function is by its name, and then you provide parentheses, and if the function requires any arguments between the parentheses, you fill them in. We have these type conversion functions. You want to turn something into an int, you can do so. If you want to turn something into a float, you can do so. If you want to turn something into a string, you can do so. It's pretty rare, in my experience, to want to turn something into a string, but you can, especially if you're going to concatenate two strings together in order to build a longer string for display later. Now, something about the int function that I don't think I've mentioned in prior classes, but somebody else is giving Python assignments that requires it, which is that int can convert like from hexadecimal. So if you need to convert a number from hexadecimal into an integer so that you can then, you know, use it, something like that, int will do that for you. Or if you need to convert it from octal, or if you need to convert it from base 2, it'll actually convert from any base. If you're not totally familiar with the idea of bases, well, that's something I strongly recommend you understand. I lecture about it in my classes, like fundamentals and stuff like that, but I don't really plan on spending an entire lecture on it in this class. You know, base, you know what binary is. It's just a series of zeros and ones that represents a number. So I think, just for funsies, let's go ahead and do that. Let's make a binary string and then convert it to a real number. Oh, excuse me, real number is a silly term. A base 10, like we count on our fingers. Okay, so I just happen to know, I'm going to type in str for num string, that, quote, or that the number 1111, 1111, 8 ones in a row in binary is equal to 255 in decimal. I've just done that conversion enough. So 1, 2, 3, 4, 5, 6, 7, 8. That's going to be our binary number. And it's a string. So if the user typed in a binary number or we read it from a file, it'd come in as a string just like any other use of the input statement. Now we want to get what it really is. X is equal to int, our num string, num str, but we want it in base 2. And this is bringing up a point that I actually wanted to mention anyways, which is the idea of optional parameters. This is an optional parameter. If you do not provide it, it defaults to 10, right? Because if the user types in that they're 65 years old, well, humans have 10 fingers, they count in base 2. They meant 65 in base 10. So that's the default that int follows. Makes sense. 99.99999% of the time, the user is going to be providing input in base 10. So they shouldn't have to do this don't type that. They shouldn't have to do that every time. So we're going to convert from binary, and then let's print it out. Print num str, comma, base 2 is equal to, or take out that word. How about just the word equals? Equals, end quote, comma, x, comma, and you don't have to put all the spaces that I do, in base 10. So hopefully when it runs, it's going to print out 255. Because like I said, all ones is equal to 255. All right, and it does. All ones in base 2 equals 255 in base 10. What if you needed to go the other way? What if you had a base 10 number, but you wanted to print it out like in base 2 or in hexadecimal? There are some functions to do that. I'm going to just put them in comments, but bin x converts to a binary string, OCT parentheses x, octal. Octal is just base 8. I didn't even teach about that in fundamentals. It's pretty obscure anymore. Converts to octal string. And then hex, parentheses x, converts to hexadecimal. I'm just going to put hex, base 16. I guess I might put parentheses 8 after octal and parentheses 2 after binary, just for those who don't have the idea of the bases. Okay, so real briefly, I want to mention why this adds up to 255, for those of y'all who haven't seen the idea before. Just like decimal numbers have powers of 10, right, where you have the tens place and the hundreds place and the thousands place and the 10,000s and the 100,000, right? Binary numbers have powers of 2. This is the ones place, the twos place, the 4, the 8, the 16, the 32. You get the idea, it's doubling each time. The 64 and the 128, and each time past that, it doubles again. So if you were to add all these together, that's, and I like adding it from right to left because I can remember 1, 2, 4, 8 more easily than I can remember 128, 64, whatever. So what we would just do is we would add those together. This is equal to 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. And if we whipped out a calculator, that would equal 255. That's enough. enough about that. Right? If it had some zeros in it, like 0010, 0010, like that. Well, there's no ones, so it's not 1 plus, but there is a 2. There's no 4s, there's no 8s, there's no 16s, but there's a 32. So that's a 2 plus a 32 equals, and then we do that, that's a 34. And I could change this string here to match that and print it out to see if it's 34, but it is. All right, so let's use the HEX function to print out whatever x is in hexadecimal. So I'm going to put another print statement. Print x, comma, in base 10 equals, end quote, comma, HEX, parentheses x. That converts this number to hexadecimal. It assumes that the number coming in is base 10, but you can assume that it's an integer. In hex. So comma, in hex, end quote, close parentheses. All right. So there we go. All ones. Remember, a byte is 8 bits. A byte where every bit is lit up in base 2 is equal to 255, and in 255 is equal to FF. True enough. Maybe I'll find a video over the topic for those of y'all who aren't familiar with the idea of hexadecimal. Optional. Y'all can watch it. Strongly recommend it after I post it if you don't already have the idea. All right. So what if we were going to make this a function that we could call and it would do all this miraculous stuff? Well, to define a function, you use the def keyword, and then you give the function a name, and then you use parentheses, and if it's supposed to accept a parameter, you fill in, you give the name of the parameter. So I'm not coming up with a real good term for this. So I'm just going to call this bin hex. And it's going to take a num string, just like we had in this variable up here. So bin hex, parentheses, end parentheses, and then tab over everything after that. Just highlight it all and hit the tab key. Boom. All right, now cut that because we're going to paste it below the function. The first unindented statement under the function. Well, heck, let's do what I was kind of recommending last class, where we were defining things like main. So let's define something called main, def main, parentheses, end parentheses, colon. And main's going to have that line of code. Notice it's tabs, so it'll be part of main. And then we're going to call the bin hex function that we just wrote up above it. Bin hex, parentheses, num str. Why would we do that? So that we could test multiple, strings. Just like I promised that that one was equal to 34, we could prove it just by passing that number into here. That way we don't have to cut and paste this code over and over and over each time we want to check, another value. All right, now we're going to do that if underscore underscore name equals quote underscore underscore main. And inside that we're going to call main. So if, these are 2 underscores, not just 1. I've received like 17 texts over this question. If underscore underscore name, and then 2 more of those, equals equals, quote, 2 underscores, main, underscore underscore, end quote, colon, then call our main function. All right. It's possible that this will run without syntax errors. Maybe I got it all right. All right, and I did. So if I wanted to change this number, like if I wanted to zero out, put in 3 zeros instead of 3 ones in the middle and run it again, I'll very quickly see the difference. Now I'm going to undo that change, but I'm going to call, just for fun, bin hex on a couple other versions. Bin hex, quote, what's 1111? Well, we'll find out. Bin hex, parentheses, quote, 1 followed by a whole bunch of zeros. Who cares how many? And then bin hex, I wonder if it'll accept negative values, like negative 101010. I honestly don't know, so this is going to be interesting for me to see. So we're calling our function 4 times with 4 different pieces of input. Hey, it worked. It said minus 101010 and base 2 equals minus 42. If any of y'all are fans of the series Hitchhiker's Guide to the Galaxy, you'll know that 42 is the most important number ever. I'm making a joke. And then negative 42 in base 10 is equal to that number in hexadecimal. And whatever. This number, all these ones followed by zeros in base 2 is equal to 4096. Makes sense because it's just doubling each time. 1, 2, 4, 8, 16, 32, 64. And then eventually, if you keep doubling, you hit 4096. Okay. So I'm happy enough that this is a demonstration of a function. That was one of the points of this. Another point is that I just wanted to show you that the int function can convert from other bases other than base 10. If we made this an 8, it would convert from a base 8 number. If we turned it into a 16, it would convert from a base 16 number. I guess let's do that. X is equal to int, parentheses, and let's put in a hexadecimal number. OX, FFEE, whatever, DD, 987654321. I wonder how big of a number it will actually support, or if that's going to break it. And then I'm just going to print X out, just to see what it does. That may be too large. Oh, why did that crash? I forgot to specify the base, and this is not valid input if we're expecting base 10. So I'm going to put a comma 16 there. Then I'm going to pause and make sure I haven't lost y'all, because I know I did a lot of typing. All right. That seems to have worked. This number, whatever that number was in hex, which I just totally made up off the top of my head, is equal to that in our own counting system. All right. Just kind of tuck that away in your brain. I don't know if we're going to hit the idea again in the class, but I certainly know that in some other classes being taught this semester, you needed to know how to do that. You needed to know these things or be able to look them up, and you needed to know this. And I don't think I taught that in the past, so I'm happy to do so now. All right, gang, if you're watching this at home and you're having problems, pause the recording, type it in. Make sure you got all your closing parentheses. One point I want to make, stymies a lot of people, is that like if you leave off a parentheses on the line above and then you run it, it'll show you this as a syntax error. And then you could stare at that all you wanted. Well, that's not a syntax error, and it's sure it's not. The problem is on the line above it. So whenever you're shown a syntax error in idle and you can't figure out what the syntax error is, you always check the line above it as well. Quite often the problem is there. Okay, so jumping back into chapter 4. I said we were going through chapter 4 and that we stopped at random numbers. I almost want to skip the idea, but random numbers are kind of fun. Maybe we'll do some random numbers. Random numbers are like rolling dice. Like if you're a D&D player, you roll up your character, you roll 3 dice for each attribute, you roll 20-sided dice to do an attack. Or you like playing Yahtzee, you roll 5 6-sided dice. So, in order to get the random number generator to work, we have to use the random library. Somewhere in the guts of Python, there's a file called random.py. And so we import that, and then we can use it. There are all sorts of functions besides just .random. And .random is not my favorite version because it generates a number between 0 and 1. And a number between 0 and 1 isn't very useful for dice games, for example, right? You know, you're going to roll up how many orcs are attacking your character, and it says 0.25. You wouldn't dig it. So there are better functions, and let's look them up. I'm going to type in Python 3 random.random and see what it points us out to. Okay, so for example, now that I typed this, it's taking us into the guts of the Python site, so we can read some documentation. All right, there's all sorts of them. But for example, here's one that'll generate a random number between the starting point and the stopping point. Like what if you want to generate a random number between 200 and 300? You specify a starting point and you specify a stopping point. And then there's randint, where you specify an upper value. Well, there sure is a lot of stuff here. Right there. Randint generates a number, and it returns it where the result is such that the number returned is between A and B. Now, honestly, I'm not sure what the difference between that and that is, except that this one allows you to specify a step. Like if you wanted to generate a random number between 100 and 200, but if you wanted it evenly divisible by 10, you put a step of 10 there. All right, let's go ahead and import. Whoops, get rid of that. I'm going to add to the top of my code, or I could do it right here inside main. I'd rather put it up at the top of the code though. So I'm going to scroll up. I like seeing all my imports up at the top. Just makes me feel good. Import random. And then down here, inside main, we're going to use that random number function, or library. R is equal to random x. X is equal to random.random. And let's print that out. And then x is equal to random dot rand int. And let's put in a 10 there. And let's print x. And then x is equal to random dot. Sometimes it'll pop up that little helpful. Yeah. If you wait a while, it'll eventually pop up this cute little thing here. Rand range. And I want a random number between 100 and 200. And I'm going to print x. Then I'm going to run it several times in a row just to see if those numbers seem random. Meaning that they differ most of the time, right? Like a dice. And what do you know? Randint is missing one required positional argument. It is, huh? Well, I better go back to the documentation to find out what randint is wanting. It's wanting two numbers, a beginning point and an end point. Again, I'm not sure what the difference between those two is, except that one supports a step option. So, I want my random number to be a number between 1 and 10. So I just had to fix that line for those of y'all following along at home. Whenever I go up and start making changes to lines above, I know it becomes more difficult to follow. All right, so I ran it and I got 0.6 whatever, 2, 112. Those were my 3 random numbers this time. What if I run it again? Different numbers, right? I hope. 0.38, 6, 122. Once more with feeling. Now, it'd be more fun to put it in a loop so that we could verify it. 0.98, 2, 132. Seems to be working. I'm going to add a step here because I want the random number to be evenly divisible by 10.
I have a question.
Yes, sir.
Will it generate 200 or does it stop at 100?
That is an excellent question. And I know why you're asking. It's because in all your Python experience previously, the last number was a one past where you wanted to go. Now, in randint, it actually will include 10. In rand range, I am not so sure. Let's find out. The way I'm going to find out is I'm going to tell it to generate a number between 100 and 110. And I'm just going to run it a couple times in a row. And if it ever generates 110, we know. All right, 100. And then I'll go back and I'll look at the documentation if this doesn't spit out the answer very quickly. I can't say that. I mean, we've seen 100 2 times in a row. It apparently would not go up to 200 in that case. I'm going to check the documentation to find out that that's true. I know that that is the way that randint works, though. It is inclusive. It will generate a 10 at times. Let's go look. Rand range. Select, say, randomly select a number from start, stop, step. Well, I don't know. I don't know why we're not seeing. Our personal experience that we just saw it run seems to indicate that it would never hit it. But although we haven't talked about loops yet, you've used loops in 113 if you've taken it. So let's write a loop that's going to call this random number function like 20 times in a row. So above this x is equal to random range, I'm going to insert a for statement. For C, which stands for counter, in range 20, 30, 20, because I want it to run 20 times, colon. For C in range, parentheses 20, in parentheses, colon. And then make sure that both of those are tabbed over. It never seems to generate 200. So despite what the documentation seems to be indicating, yep. So excellent question, and no, it would not go to 200, it would go to 190. I hadn't really noticed the rand range function until this class right here, so I hadn't investigated it before. I always use randint. And if we'd said 100, 200 there, then actually we would have been able to get, 200 because it is inclusive. So I'm going to add a comment. From 1 to 10 inclusive, and I'm going to put from 1 to 190 by 10s. Not from 1. From 100 to 190 by 10s. And it's possible that if we read the documentation more carefully, it would specify that. All right, what could you use random number generators for? Games is what typically occurs to me. Dice games or positions of enemies on the board, or whether somebody's attack was successful or something like that. Other uses could be maybe you have some kind of formula and you want to test the formula over a repeated amount of time, over and over and over with different input. Then you might make a loop that would generate 10,000 different numbers and pass that into your formula. You might be wanting to measure the speed of the formula over a certain amount of time. That'd be another use for it. And I believe that random numbers are used for decryption efforts sometimes. Not absolutely sure how that is true, but you generate a random number and then you see certainly for encryption, then a random number could be chosen, and then your encryption key be based upon that, so that it's more difficult for someone to guess. This is not actually what's known as a true random number. It's just about impossible to generate a true random number in computers. What they are is they're pseudo-random numbers. Pseudo meaning kind of random. And what does that really mean? It means that if you start at the same number, it will always generate the same sequence of numbers, because the next random number is mathematically based on the last number. So like if the first call to randint generated a 50, then the next one would use that 50 and permutate it, kind of like that chaos function that you may have done in your homework. And maybe the next random number would be 210. Well, if it ever started at a 50 again, then the next number would still be 210. And so to fix that, there's the idea of a seed. You can tell it what number to start counting at. The first number in the sequence, and then when it calls random int, it'll generate the next number in the sequence. And you want that number to be pretty random. And so a lot of people will use the number of seconds since midnight as that seed, right? That way, it's very unlikely that every time you run this program, it'll be exactly at 7:45 and 37 seconds, right? It won't be the same number of seconds past midnight every single time. You might just took that idea away in your head. Random number sequences have a seed that kicks them off. Now, the Python library is giving us a seed already, probably based on time, I don't know. If you use the C++ random number generator library functions, they are not seeded. They start with 0, so they give you the same sequence every time, unless you seed. But I am quite sure that if we go and check the documentation, we will see that there's a way to specify the seed. Yep. So, I'm going to put a call to seed up here at the top before my first random call. And you can pick any number you want. I'm just going to seed mine to 0. And now every time I run it, I'm going to see the same sequence of numbers. Now why would you want that? And what do you know? It's supposed to be random.seed. Why? Because the seed is in the random library. So I have to prefix it by its name, unless I do something special in the import. So random.seed. I apologize, that was not an intentional mistake. Now every time I run it, I should see the same sequence of random numbers. 7, 100, 140, 180. Run it again, see if that's the case. 7, 100, 140, 180. That's the idea of a seed. Seed value is just a starting value for all the subsequent random numbers to be generated via whatever mathematical formula it uses. All right, anybody need any typing time? Slow me down if you do. Folks at home, pause the recording, and if you have syntax errors, just eyeball it very carefully, and usually this code is also put in some fashion in the notes. Go back to our homework. So, this textbook is also introducing the idea of for loops pretty early. So they're showing pretty much the same thing we did. For I in range 10, so it's going to generate 10 different random numbers, our for loop is. Now the range statement starts at 0 and goes up to, but does not include the last one. So I will equal all the values between 0 and 9 in turn. It'll equal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we may as well prove that in our code. I'm going to come down here underneath my for statement and add another for loop, just to prove that. I could even copy that last one. For C in range, parentheses 20, in parentheses, colon, print C. And that's just going to print 0 to 19. Now there's nothing random about this one, so it's absolutely going to be the same sequence every time, 0 to 19. There we go. Why does it stop at 19 rather than going to 20? Just because that's how the inventor of Python made it. Zero-based indexing quite often does that. What if you wanted to start it at another number besides 0? We could say, I want you to start at 10 and go up to but not include 20. So now it's going to count 10 through 19. There, like that. 10 through 19. I'm going to put a comment here. The range is, or counts, from 10 to 19. So to choose an element from a sequence at random, you use choice. Now again, we're introducing topics before we've introduced them. We haven't talked about what this is. Now if you took fundamentals, you know what that is. That's a list. You may as well play with that too. The sooner we see something, the more we'll recognize it the next time we see it. So we're going to make a list. I'm going to just store it in a variable that's a capital L for list. And I'm going to push all this stuff up to the top of the screen. Make it easier to see. So L, whoops, needs to be unindented. Well, one indentation level because we're inside a function. L is equal to, and then I'm just going to list some colors. So that's a square brace, not a parentheses. And then quote red, end quote, comma, and then just list some colors. I don't have to list the same ones I do. Okay. I want to go and comment out that seed choice so that it'll make a different choice each time. Otherwise, it would always pick the same color. So I'm going to scroll back up, find that call to seed, and comment it out. It's way up. There it is. All right, now what was that function called? The one that picks a random choice? Okay, what do you know? It's called choice. Random.choice. Let's do that. Print random.choice, parentheses, L, two close parentheses. And I'm going to copy and paste that a couple times just so that I get to see colors printed out over and over. All right, so I got blue, silver, black, and blue. Yellow, yellow, black, and blue. Wonder why it's always ending in black and blue. I want to see it. Okay, black, red, black, red. Okay, so yeah, it's picking randomly from this list. That's kind of neat. Maybe you're going to have a card game, and so you're going to list, 52 cards, something like that. And so you're going to pick a random card out of there. That might be fun to do later when we're talking about lists a lot more. So math functions. Besides random numbers, which you're not going to use that often, there are math functions, which really you wind up using more often, right? So there's log 10. Take something to log 10. Math sine. Take the sine value. Now this requires radians. So you can't say I want the sine value of 45 degrees. You would first have to convert the 45 degrees to radians before you could call that. I don't particularly see that we're going to be using sine and cosine and tangent, and I'm not sure we're going to be using log. But we have those functions available to us. Here's a useful one, square root. Math.pi is another useful one because for some annoying reason I keep asking people to calculate the volume and surface area of spheres, circles and things like that. We may as well use that one. Let's get that. So, import math. Actually, I'm going to change the syntax up. From math, import pi. And then area of a circle is equal to pi r squared. So pi times, we need a value of r. Let's say it's 3 to the power of 2. Let's print out the area. Print area of circle with radius 3 equals, end quote, comma, area. Let's make sure that works. And the output is getting to be so much that, all right, the area of a circle with 3 is equal to 28. Pi is 3 times 3 times, yeah, that looks about right. Okay. So if you need math, if you need pi, that's one way to do it. Now this alternate syntax, what it does is it brings that function in without requiring the extension of the name of the library as a prefix. If I just done import math, rather than from math import pi, then when I called pi, I would have to use math.pi. In my random, I'm going to undo that. In my random number generator, if I'd done from random import random, then I would not have had to prefix all of these functions with their library name. Now I kind of actually like adding the prefix, right? I probably, most of the time, would rather see the name of the library in front of it because it gives you useful information, right? If you just saw choice in the middle of a program, you'd have no idea what it was. But if you see random.choice, you have a real good clue of what it's doing. Now pi is so obvious that you don't need to see math.pi in front of it. So I'm just going to import math. So I get all the functions, not just one, and then I'm going to print, quote, square root of 10 equals, end quote, comma. And now I need to use the square root function, which is sqrt, but I didn't import it with this special syntax, so I'm going to have to prefix it with the library math. math dot sqrt. Parentheses and parentheses. Notice that every other time we've used something from a library, we put parentheses after it. That's okay, I've made a mistake there. This is the first to spot it. This is not going to do anything. If I ran it, it'd be a syntax error.
You don't have an argument?
Right, it's square root of what? So, square root of 10. Anyways, where was I going with that? Yeah, every other time we've called a function every other time we've used a library, we put parentheses after it. That's because these are all functions. But pi is not a function. Why is it not a function? Because it's always the same thing, right? These are all calculations. They do different things based on the data given to them. But pi is not a function because it's just a mathematical constant. And so the square root of 10 is equal to that. I'll buy it. That's almost pi. Not really, but. And so along with sqrt, there's also, math.sine, math.cosine, math.tangent, all the other math functions that you could possibly want. There's a trick to getting the square root of something, by the way, using the exponent function. Here's another way of doing it. X is equal to 10 to the power of 0.5. That'll also take the square root of it. Let's print that out as well. Print X. They should be the exact same thing. Sorry, I'll bring the code back. Yep, they're the same thing. So why do they have a square root function? Well, because this looks better. This is more understandable than this, right? This requires you to understand that the square root of something is equal to that to the power of 1 over 2. The cube root of something would equal that to the power of 1 over 3. You know, so 10 to the power of 0.33333 would give you the cube root of 10, and so on. If you ever have a calculator that has an exponent button or a power of button, but it doesn't have a square root function, that's how you can get the square root of it. Just take it to the power of that. Am I going to ask you that on a quiz? No, that's just something to tuck away. Adding new functions. You can add your own functions. We already have. We added one called main, and we added one called bin hex. Here's theirs. If you're a Monty Python fan, you'll recognize I'm a lumberjack and I'm okay. I sleep all night and I work all day. Right? So this is just a function that prints things, and it doesn't take any arguments. So there's nothing defined between the parentheses. It's just going to print the same lyrics over and over and over. And we could do something like that, but I almost want to start a new file. This one's getting really long. I guess I'm going to go up to the top and start adding stuff to the top of the code rather than the bottom of the code. So, above def main, we're going to write a function called lyrics. But we're going to base it upon a number that they pass in. And if x is equal to 1, we're going to print something from the song Umbrella by Rihanna. So print under my umbrella, umbrella. All right. You know what? I'm going to exhaust my idea of lyrics that I can come up with on an instant pretty quickly. If x is equal to 2, then that means that it's the Mary Had a Little Lamb song. Print parentheses, Mary had a little lamb. If x is equal to 3 colon, let's come up with another song. Print, so call me maybe. All right, this is kind of a silly function. And then lastly, else colon, print, I don't know that song. And then inside main, I'm going to call lyrics. Lyrics 3, lyrics 2, and then lyrics 1. And then maybe lyrics 0. Now there is no song 0, so that should give us an error. Not an error, but it should print out, I don't know that song. All right, so print it out. So call me maybe, Mary Had a Little Lamb, Under My Umbrella, and I don't know that song, which is reasonable because when it called the lyrics function with an argument of 3, our parameter was filled with 3, and so it went down to this part of the if statement and it printed, so call me maybe. That was the first thing that happened. The next time, the argument was 2, so the parameter variable got filled with 2, so it jumped down here and print Mary Had a Little Lamb, and so on. So that's how you define a function, and that's how you invoke it. We're going to introduce the idea of a default value for a function. What if we like Under My Umbrella so much that that's the one that we want to print in any case where they don't specify a song? I'm going to come up to where it says X here, and I'm going to give it a default value. So that's the line that I'm changing there. I just added X is equal to 1. So if we ever call lyrics Without a value, it's going to print that. So when we invoke lyrics without a parameter, like here, I'm going to call it 4 times in a row with no parameters. Then when it enters the function, I said that wrong. I deleted all the arguments, so the parameter gets set to x, gets set to 1. So it's always going to print under my umbrella. If I scroll up, that'll be the case. Under my umbrella, 4 times in a row. Now, if you don't have a default value, it'll be a syntax error. So if I get rid of that, it's going to complain because I'm not providing any arguments to fill that parameter. Boom. It says the lyrics is requiring 1 required argument. So we had to have an argument here to fill into x because we don't have a default value for it. I'm going to give it a default value. And maybe I'll fill in, like that. Just to prove that it works with no argument provided, and it also works if an argument is provided. So I added my default argument back in. I changed my test code a little bit. I'm going to run it, see what the result is. Yeah. So when we invoked it with no arguments, it printed out our default, our favorite song, Umbrella. Then it printed out Call Me Maybe because that's song 3. Then it printed out Mary Had a Little Lamb because that's song 1. And then back, 2. And then back to Umbrella as song 1. We'll probably find better uses for default values than just doing, songs. Like, let's write a hello function that will print out hello followed by somebody's name. But if they don't give us a name, then we're going to print something else. So define hello, parentheses, name, equals I don't know who you are. And then we're going to print, well, hello there, end quote, comma, name. And then we're going to call hello a few times. One time we're not going to provide any value at all. The other times we're going to provide some names. So hello, Rihanna. Whoops, I need to put quotes around it because it's a string. Hello, how can I type? Where's the quote? There it is. Rihanna. Then we're going to say hello to Lady Gaga. And then we're going to say hello without knowing the name of the person we're greeting. Now I'm tempted to change that to who are you anyway. Invalid syntax. Who spots the error?
Semicolon.
No colon there. Yep, put a colon. So that line was an error. Put the colon there if you typed exactly what I did. All right, and so what did it do? It said, well, hello there, Rihanna. Hello there, Lady Gaga. And then hello there, I don't know who you are. The third time it printed that because we did not provide an argument, so the default value was used. That's probably about enough of that. Let's go back. I've wandered far afield from text. So DEF is the keyword that indicates that it's a function definition. And then the name of the function is print lyrics, and you can give this any name you want to. It just has to follow the variable naming conventions, which is no numbers at the beginning. And then there can't be a space in it, but you can use underscores. If there's a pair of parentheses but nothing in it, that means that it does not take any arguments. Everything after the function has to be tabbed over. The first statement that is untabbed is the end of the function. And if you've taken other languages, you're used to being able to do this, right? Don't type this because putting an open brace at the beginning of your function, putting a closed brace at the end, and that marks off the entire function. But not in this language. In this language, indentation is king. That's how we define what code is included in a function and what is not. So all of this stuff is indented. So this is all part of the main function. This is the first unindented line, so it marks the end of the function. Just like this. All of this is part of the lyrics function. The hello function only has one hello line followed by an unindented line, so that's the only line of code that's in the hello function. So, if you type a function definition in interactive mode, the interpreter prints ellipses to let you know that the function is not complete. Well, that's all well and good. What it's saying is that if I launch the shell, I can define a function right then and there. def hello, parentheses in, parentheses in. You don't have to type this. All right. Supposedly it's showing dot, dot, dot. I don't see them. Nope. Well, okay, ignore that. The online text says that it would be putting dots there to indicate that we're still in the mode of declaring the function, but I don't see them. I wonder why the word all is colored, highlighted there. So, here the author has written two functions, one called print lyrics and one called repeat lyrics. And then if you call repeat lyrics, it runs up here and runs repeat lyrics, which calls print lyrics, and then it calls it again. So it would print out the message, I'm a lumberjack and I'm okay, I print all night and I work all day, twice. So flow of execution. The flow of execution is what parts of the code are run in what order. And you'd think it'd be pretty easy. It's top down. But not really. Not completely. What do I mean by that? Is this the first thing the program does? Is do a conversion? No, it's not. If I run it, well, the conversion doesn't happen until after it does all this stuff about song lyrics. Why is that? Because it's tucked away in a function, so it's not the first thing that's executed. The order of operation is that it runs through here, and each DEF defines a function but doesn't execute it. And eventually it finds a line of code that is not a DEF. And that is the first thing that's actually run. So it runs all the way through this, defining function after function. It finally hits this line of code. And if we're running the program with the run option rather than doing an import, then this will be true, and it'll go ahead and execute main. And it'll jump up to main, and it'll run this. And then it'll call hello. It'll print out hello a couple of times. And then it'll call the lyrics functions a couple of times. And then we get down to the bin hex function, and it calls that. So the order of operation is, generally top down, but it's very dependent upon what is defined in these compound statements. A compound statement being, something that ends in a colon and then has a block of code after it. And so DEFs are skipped in execution until they're called. If we didn't have this line of code in here at all, I'm going to delete it, but don't. And when I ran it, wouldn't do anything. None of our functions are being called. However, they're loaded into memory. Well, that was wrong. That was supposed to be a binary number. But anyways, you get the idea. When I ran it, it defined all those functions, but it didn't call any of them. And it's supposed to be a string. That's what my real error is. I forgot my own bin hex function. Right. Hello, like that. And then song lyrics or whatever the name of that function was. Yeah, so if you want to load up your functions, and then call them interactively in your shell, you can do that. Undo that. Almost time is done. So parameters and arguments. This is a good place to end on. The thing defined inside the parentheses is the parameters. When we call it, we provide an argument. Subtle difference. And I'll sometimes mess them up. And it's not like the programming police are going to come beat you up if you call that a parameter. But it's really an argument that fills a parameter. Now what is a parameter? It's a variable that accepts an argument. Kind of a circular definition. So Bruce is a variable that can then be used inside the body of that function. Then there are fruitful functions and void functions. A fruitful function is one that returns a value. A void function is one that doesn't. We wrote a whole bunch of functions and only one of them was a fruitful function. Only one of them had a return. Maybe none of them had a return. This one doesn't have a return statement, so it's called a void function. It doesn't matter whether we pass something in or not. That's not what makes it a void function. The void function is dependent upon whether it returns anything. Lyrics doesn't return anything. You call it and great. Hello doesn't return anything. You call it and great. Let's write a little function that does return something. We're going to call it fruitful. And what's it going to do? It's going to return apple. So inside it, since it's a fruitful function, we need to store its return value. So f is equal to fruitful. Parentheses in parentheses, and then print f, just to prove that it worked. And that'll be the last thing we do today. So the rest of them are all void functions. This is the only fruitful function we have. I'm going to add a comment to it. Fruitful function because it returns a value. Now in Python, every function actually returns a value. But the value that it returns is a special keyword called none if you don't specify one. All right, so up here it printed apple because that's what it returned. If I comment this out though, and I make it do something else, like I don't know what, maybe just set x equal to 1, who cares? Then when it prints out what f is, even though it doesn't have a return statement, it returns something. It returns this little word none. That's how you can indicate whether you can check to see if something returned a value or not. We could do if f equals none, then we know it didn't return anything. I'm going to change that back to return apple so that I can see that it worked. I'm going to delete that line. Are there any questions? Let me make a Dropbox, and then if you have syntax errors, I'll be glad to help. I think that's the last thing we did, so I'll leave this on the screen. Pause it if you need.